Hello, ladies and gentlemen. Today is a big day in geometry. We learn about special right triangles. These are like your VIP triangles, okay? So you're definitely going to want to pay attention. Make sure you're jotting down any good questions you might have. Follow along in your foldable pen or pencil, something to write something down with, and a calculator. Okay, so the first one we're going to look at is a 45, 45, 90 triangle relationship. So I just want you to watch and listen here closely as we go through this. Now, since I have a 45, 45, 90, all I'm going to do here is I'm going to write in those corners. This would be a 45, this would be a 45, and here would be my 90. Now again, as we learned a long time ago, when I have two congruent angles, this means that the sides opposite them also have to be congruent. So if I have two congruent angles, this means I must have an isosceles triangle. Now, we have formulas that help us with these now, and we're just going to kind of develop those formulas as we go on here. But all I'm going to do here is throw in a couple numbers. So first numbers I'm going to throw on, I'm going to throw a 1 here. So if I throw a 1 here and I throw a 1 here, okay, our goal is to figure out that hypotenuse. So again, since I have two sides of a right triangle, I should be able to use the Pythagorean theorem to help me find that third. So I get 1 squared plus 1 squared equals x squared. Okay, so that goes 1 plus 1 equals x squared. 2 equals x squared. It looks like x is going to equal the square root of 2. Okay, so that's the first example. Now, I'm going to erase these, and I'm going to throw in different numbers. Like, let's say I throw in the number 3. Throw a 3 here, and that means this would also have to be 3, because again, we have that isosceles triangle. So again, let's use the Pythagorean theorem to help us solve for that hypotenuse. Looks like I'm going to get 9 plus 9 equals x squared. 9 plus 9 is 18 equals x squared. Take the square root of both sides. I get the square root of 18 equals x. Well, from there, we could break that down into the square root of 9, square root of 2. 9 goes poof, we get 3 square roots of 2 for x. Okay, we're going to erase that. We're going to do it one more time with, let's say, the number 7. Let's do 7. I'm going to do that work up here. So if I do 7 squared plus 7 squared equals x squared, I get 49 plus 49 equals x squared. So then I'm going to get 98 equals x squared. Take the square root of both sides. Well, it looks like 98. I'm going to have to break that up. It's going to break up into the square root of 49, square root of 2. So it looks like x is going to give me 7 root 2. Now, when you look at all three of these hypotenuse, what happened when we plugged in different numbers? What is a common theme in all of them? A common theme in all of them is that root 2. So what we notice here is that the sides, in comparison to the hypotenuse, it looks like I'm just going to end up taking 7 times root 2 to get my hypotenuse. Just like over here when my side was 1, I took 1 times root 2 to give me the square root of 2 for my hypotenuse. And when my leg or my side was 3, I ended up taking 3 times root 2 to get my hypotenuse. So that leads us to this formula or equation that's going to help us to solve every single 45, 45, 90 degree triangle. So the theorem you're going to want to write in your notes under 45, 45, 90 is hypotenuse equals leg times the square root of 2. Now these formulas come in handy if you memorize them, because as we move forward, this is how we're going to solve these types of triangles, these special 45, 40, 90 degree triangles. So make sure you jot that down, and we'll move on to 30, 60, 90s. The next special triangles we have are 30, 60, 90s. So we're just going to simply watch how this kind of developed and came to. So if we see here, we have a triangle, and this is an equilateral triangle. So what equilateral means, hopefully we remember that equilateral means all equal angles and all equal sides. So when I do this, again, to get my 30, 60, 90, I'm just going to throw in some side lengths. We'll say this is 6, meaning this is 6, and this side's also 6. So all I'm going to do here to create a 30, 60, 90 is I'm going to draw this altitude, and I'm going to divide this, and I'm going to cut this directly in half. So what happens then is we're going to ignore the left side of our triangle, I'll erase those little pieces. Ignore that left side of our triangle. I'm going to erase these up here quick. Okay, and I'm going to end up creating this 90 degree. Now again, since we cut this top 60 in half, we're going to have a 30 degree here. Since I cut the top angle in half, what do you think happened to this bottom side? Well, likely it also got cut in half. So this bottom side then becomes 3. So notice here, again, I have a right triangle, and let's see if I can figure out this third side. So if I figure out this third side, let's do the Pythagorean theorem. So I get 3 squared plus x squared equals 6 squared. 9 plus x squared equals 36. If I get x squared alone, it looks like I'm going to get 27. Take the square root of both sides. X is going to equal 27. I know 9 goes into 27 3 times. So it looks like x is going to equal 3 root 3. And you're probably thinking, all right, Kessler, makes sense. I've done the Pythagorean theorem a bunch, but can we develop, again, some sort of pattern that's going to happen if I were to change my numbers up? So without having to redraw my picture, I'm just going to change this number 6. I'm going to change that number 6 to, let's say, 10. So when I change that number 6 to 10, again, since I cut this whole equilateral in half and we got 30 degrees on top, that means the bottom would become 5. And again, we have a right triangle with 2 sides. I need to find the third. So let's take x squared plus 5 squared equals 10 squared. I get x squared plus 25 equals 100. X squared equals 75. Take the square root of both sides. I know that 75 breaks up into the square root of 25 and the square root of 3. So it looks like x is going to equal 5 root 3. So again, when I compare these two, and I compare them to the other lengths that were given in my triangle, it looks like I'm taking the shorter side and multiplying it by the square root of 3. Just like when I had a 3 in there, I took the 3, that shorter side of 3, and multiplied it by root 3. So again, there's that similarities that come in these special triangles. So let's jump to the next slide and see what we get for our formulas for a 30, 60, 90. So again, in a 30, 60, 90, we have 2 this time because again, we don't have just 2 different angles, we have 3 different angles. So this time, again, write these down, jot these down. It's really good for you to have them memorized. It might take a little while, but once you have them memorized, it makes the solving process way easier. All right, so here we go, example 1. We are going to want to first off figure out which of the 2 special right triangles we're dealing with here. So when we look inside this triangle, I need to determine, is it a 45, 45, 90, or is it a 30, 60, 90? Well, if you look here, the label tells us immediately that it's going to be our 30, 60, 90. So we have a 30, 60, 90. Now, from there, we were going to want to label what side's what, because again, in a 30, 60, 90, that means we're going to have a short leg, a long leg, and a hypotenuse. Well, again, right off the bat, the easiest one to label would be my hypotenuse. So this side's going to be my hypotenuse. Now I have to determine my short leg and my long leg. Again, look at those angles. The 30 and the 60 help you to determine which one's which. So the side across from my 30 degrees is going to be my short leg. And the side across from my unknown over here, which technically if we solved this, we would figure out that it's 60 degrees. This side across from my 60 degrees is going to be my long leg. So now comes into play those 2 equations that we're going to have to memorize. So in this one, we're given our short leg. So this one, we can use either or. So if we wanted to solve for my hypotenuse first, we're going to want to use the top one. And from there, we're just going to fill in what we know when I look at that equation. So hypotenuse is x equals 2 times my short leg, which is 4. So when I solve that, x is going to equal 8. So we just figured out that the hypotenuse in this triangle would be 8. Now, on the other hand, we still have to solve for y, and y again is my long leg, so we're going to have to use the equation that involves the long leg. So again, we use that equation, we just plug in for what we know. Well, we know the long leg is y. The short leg we have is 4 times the square root of 3. So here I have 4 times the square root of 3. Now again, remember, can I multiply the 4 and the 3 together? I can't because one's inside the radical and one's outside. So my long leg here would be 4 times the square root of 3.
So just like that, we found the hypotenuse and we found our long leg. Again, in example 2, we're going to start by figuring out what type of special triangle am I dealing with. Notice again here, it looks like we're going to have a 30, 60, 90. So again, we have a 30, 60, 90. From there, let's label what we have. So the easiest one again right off the bat is to figure out my hypotenuse. From there, the side across from my 30 would be my short leg, and the side across from my 60 would be my long leg. Okay, again, we're going to have to bring out those formulas that we know. So when I bring out those formulas, it looks like I have a hypotenuse and I have a long leg. So from here, we have to figure out where to go next. Now, could I start by finding my hypotenuse first? If we look here, hypotenuse, you must know the short leg before you can find out the hypotenuse. So this one, we're going to have to find our short leg first because our short leg is unknown. Well, now that we see what it is known, we have our long leg is known, so we're going to have to use this long leg equation to help us solve it. So again, let's plug in for what we know. We know the long leg is 9 equals short leg, which we have as x times root 3. Now this one looks like it's going to be a little bit more tricky to solve here because I got to get that x alone. My goal is to figure out what that x is. So how do I get rid of this multiplication? Well, it looks like I'm going to have to divide both sides by root 3 to undo that multiplication. So then when you look on the left-hand side, it looks like I have a fraction, and again, I have that denominator. I can't just divide 9 by 3 because 9's outside and 3's inside. So it looks like I'm going to have to rationalize. I can't have that 3 because over here it's going to cancel, but I can't have that square root in the bottom, so how do I get rid of it? I multiply it by itself. So I'm going to multiply top and bottom by the square root of 3. So I'm going to get 9 square roots of 3 over square root of 3 times the square root of 3 would be the square root of 9, which again, 9 is a magical number, so it looks like that's going to turn into 9 square roots of 3 over, poof, we get a 3. And then notice we have a 9 and a 3 on the outside, so we can simplify that. Looks like x is going to equal 3 root 3. So again, all I had to do was figure out what I knew and plug into one of those two equations that would help me figure out. I had to find the short leg first because now that I have the short leg, I can go ahead and I can solve for my hypotenuse. Again, you're going to plug into this equation. So the hypotenuse over here we have is y, and then that equals 2. And the short leg we just found to be 3 root 3. And from here, it just becomes an equation that we are familiar with solving. Again, what numbers can I multiply? Only the numbers on the outside. So it looks like y is going to equal 6 root 3. So again, we went through the steps of finding our hypotenuse and our short leg. Again, short leg you need to know before you can find that hypotenuse.
All right, for example 3 here, since we've already done a couple of our 30, 60, 90s, I'm going to have you guys try this one on your own. And if you can't get it, I want you to give your best effort, and then we will come back when we get to class and we'll discuss this one. But again, I want you to come with some effort, because if you try it and you get stuck, you'll at least know specifically what questions you have when we jump to class.
All right, example 4 then. Again, right off the bat, we want to make sure we decide which one of my special rights I have here. So if you look at this one, it looks like this time we're going to have a 45. So that means if I were to solve this triangle knowing that they all equal 180, we'd find that this side would be 45. Looks like I'm going to have a 45, 45, 90. So again, in a 45, 45, 90, we have legs. And we know that the legs, since we have two congruent angles, we're going to have two congruent sides. And those sides are going to be the ones that cross from those congruent angles. So any 45, 45, 90 again is just that isosceles triangle. So we have two congruent sides, and then we have one hypotenuse. So right off the bat, you should be able to determine that x is going to equal 10. And then we might have to use our formula here, our equation that we have to memorize to help us solve for that hypotenuse. Again, notice we have one of our legs. So from there, we can just plug in for what we know. We know the hypotenuse is y. The leg, we realize, is 10 times root 2. Again, take that second to determine, can I multiply the 10 and the 2? You cannot because one's outside, one's inside. So it looks like my hypotenuse here would be 10 root 2. And again, I was able to figure out that x equals 10 because I was given an isosceles triangle. We knew right after the bat, once I knew it was a 45, 45, 90, I could determine that the two sides opposite are congruent, therefore x equaling 10. Now I know both legs, I can use that leg to help me find the hypotenuse, which is y equals 10 square roots 2. All right, our last example of the day, again, right off the bat, we're going to want to determine what type of special right triangle we're dealing with. But in this instance, we're not given any angles. We're given markings. So in this instance, in this example, we're given that we have two congruent sides. So when I have two congruent sides, again, if I have two congruent sides, it's safe to say that I have two congruent angles, and those would be the angles opposite of them. And notice if I've already used 90 degrees, what did we call it when we had an isosceles right triangle? Hopefully we're starting to remember that these would have to be 45s. You could use your 180 trick with triangles and then say 180 minus 90 divided by 2 because we have two congruent angles. Or you could just memorize that this has to be 45, 45, 90 because of the trick we learned today. So again, right off the bat, we determine that this is a 45, 45, 90. From there, we got to determine what we have. So let's label our sides. We know that this side's got to be my hypotenuse, and this is a leg, and this is a leg. So we know that x and y have to be the same thing because of their markings, and this one we're given the hypotenuse. So again, recall that formula or that equation, and let's plug in for what we know. So it looks like we know that the hypotenuse is 6 root 2, and the leg we don't know, but we could use either x or y. I'm going to use x times root 2. Again, I can't multiply here, but I'm trying to get x alone, so I got to do reverse PEMDAS to help me solve. And to get rid of that multiplication by root 2, that means I'm going to have to divide by root 2. So divide both sides by root 2. And if you notice here, those root 2's on both sides are going to end up canceling. So I'm going to get x equals 6. So again, now that I know that x equals 6, since it's an isosceles triangle, we know that x is congruent to y. We also know that y equals 6. In some cases, it's not going to be just easy division like this. The 2's might not cancel, but again, knowing that we got to get that x alone by dividing, maybe have to get that radical out of the bottom. In this instance, they canceled, so I didn't have to do any rationalizing, but in some cases, you might have to. So I want to thank you for taking good notes. This is an important video, so make sure that if you have any at all questions, you write them down. If you are stuck, make sure you rewatch the video because this is something that you're going to want to take forward with you. You see this on the ACT, you see this on the Aspire, but again, important video, so make sure that we are understanding as we move away from this or asking questions to help get us to that understanding.